Hi, Muhammad.
Hello, Professor. How are you?
Good, and you?
I'm good.
Glad you are finally, joining the Zoom meetings. Actually, no one here with me,
Really?
so I wish you come. Kunji also joining
No, I couldn't
Zoom.
make it. I missed the train, so I had to join the meeting in
No,
Zoom.
no, that's okay. I mean Zoom, okay, but no students in person with me right now here in Mayo Hall.
Oh,
Yeah, that's okay. It's okay. Yeah, I'm now alone here. I'm
the
not sure.
problem with the train, it's
Should I?
in each 1 hour.
Okay, that's okay. All right. So it's better than nothing. That's why I turn on my Zoom to see if anyone is around the waiting for Zoom. So glad to you have Mohammad and Kunji. How are you guys?
We're fine, Professor.
Good, thank you,
Kunji,
Prof.
are you there? Okay, good. Anyway, I'm going to
I guess
share.
Bilal will join the meeting too. He just talked to me.
Okay, we'll see. Okay, sharing. So you guys see my screen, right?
Yes.
Okay. I'm also, I think I am recording this lecture. Okay, the special announcement today. Next week, we're not going to meet here in person. Um, Mainly because I have a time conflict. Oh, I have a student walking in. Glad he's joining me. Um, I think it's Gianni, maybe. Next week, very special announcement from the president of the Mercer University. Um, Welcome, Gianni. You're the
Hey,
only one here.
for real?
Yeah, you can take all the desk. By the way, two other students on Zoom.
Two students on
Yeah,
Zoom?
yeah. I didn't. Oh, one more here joining. Oops. Did I get the? Let me check. How many do I have? Oh, I saw one. Okay. All right. So because of the time conflict, um, there's a very special announcement from the president of Mercer University. Time conflict. They ask us to join the Zoom or in person. I think it'll be the meeting. I think 11 o'clock next Tuesday. So we are not going to meet, but say something. I'm going to record my lecture, and then I will let you follow my lecture. We cannot skip. Okay, so we have a very tight schedule. So the course material should be covered the way that I originally planned. So there's no other enough room that we can skip and enjoy. So next week, once again, we're not going to meet this time. Instance try to join. Where can I see that person? Oh, here. Oh, two more students. Oh. Okay. So I have a Marco and Capel with me.
Hi,
Hi,
Professor.
Capel.
Good morning. Hi,
Yeah,
Professor.
Marcos. I saw one more student walking in. Not sure. Is it to this class? But anyway, so I'm going to make an announcement again. Next week, next Tuesday, don't come to in person here, Dobbsbury campus. Don't try to join Zoom. Instead, I'm going to post my recording, mainly because time conflict. The Mercer University has a special the faculty gatherings. I think Mercer University school structure will be dramatically changed. I do not know how, but cybersecurity and computer science may not be with mathematics. I'm not sure. There's some rumor, and the schools may be reshuffled. I'm not sure where we are going. We'll see. I do not know yet. Right. So that much important. So I want to hear directly from the president. So next Tuesday, no Zoom, no in-person meeting, but class will run as we originally scheduled. So you have to check out course material and my recordings. If there is some homework assignments, do homework. Okay? Clear, everybody? Thank you, Gianni. But what about
Yes,
the guys?
Professor.
Okay, great. Thank you. All right. So today, as you noticed, lots of lecture notes are posted. So I have to go quick. Okay. Sometimes skip some. All right. Oops. Here's my. All right. So we'll look at DML, Data Manipulation Language. So taking a small database, as you can see here, start from ER diagram. ER diagram is the outcome of conceptual design. So we have ERD here. From this ER diagram, students and enrollment, there is a many-to-many relationships. Therefore, the box will be converted to a table as well as diamond. So diamond is also a table. So whole thing is called database. Schema. Database schema is defined in a DBMS. Ours is MySQL. Oh, good participation. Wherever belong. Should I make another announcement? Okay, I'll do that. Another announcement. Okay. Good morning, Bilal.
Hello, sir.
Okay.
Hello, everyone.
Good. I need to make repeat the same announcement again, Bilal, because this is important. Next Tuesday, we are not going to meet in person, no meeting over Zoom, but class will run. Class runs as normally because the course materials allocated for this semester, for this class, this course is is really more than enough. So we don't have any time that we can relax or enjoy. One of the person coming in, I was working, so he's not to our class. Okay, so most of our students right now on Zoom, and except one, Gianni is with me here in Topsbury campus. The reason for not meeting you either Zoom or in person next week is because we will have a very, very special the announcement from the university president at 11 o'clock. According to the rumor, there will be a dramatic reshuffling of the university structure. Part of that affects to our program, cybersecurity. Not program itself, but they're going to put our program into another umbrella. I'm not sure where. Okay, I'm not sure. Umbrella still remain the same, but maybe our department has multiple other programs. For example, mathematics. Will we go together with the mathematics for the future, or we go with some other programs? So that type of things will be announced the next Tuesday. So rather than hearing that from another rumor, I want to hear directly from the university president. So all the lecture notes, my recording, and also maybe homework assignments will be posted so you can follow that. Okay? Clear? I think Bilal, this is a third time announcement. Is this clear, Bilal?
Yes, sir.
Okay. All right, let me keep going. So I'm going to bring up. This is by default. This is a black background. So I am going to open up white background because our students wants to see the white ones. So this is white ones. And why this is going back? Okay. And then I was trying to change this terminal setting here. Okay. This isn't really. I'm trying to see the font size. Change the font size. Here. No. Okay. That's okay. I can do it. I'm going to open up my SQL. So USR local MySQL bin MySQL minus U root minus P. Is it Mercy 1, 2, 3? Right capo? Okay. Show databases. Okay, still have that. Not CD, but we have to do use college. Show tables. Probably we went to the table course, department, and students. I want to make this a little different ways. I want to make it simple as you look at here. So what I am trying to do, I want to drop the tables, table course, See what happens if I drop course. I think drop course will be okay. But what is a drop? The command drop means I want to remove the table, entire table definition as well, table relation schema as well. But if I want to drop relation schema of department, anyone can guess what would happen if I try to remove the departments? Hmm? Or it can be deleted? There's some linkages between department and course and department. Yeah, department, students, and therefore course, I believe. Because there's a foreign key. Students, before students enrolled, before student table is created, department table first created, because there is a foreign key constraints. But if I delete department first, then there is some error, right? But if I want to delete student, still there is this, I think, some problem because some students already registered the course. Okay, so there is a problem. So it should delete from something fully dependent, some table that is fully dependent on something. So if that table is deleted, it doesn't affect to others, because that is the end node. So let's try. If I want to delete course, oops, what happens? Oh, there's a typo. Let's do that again. Department table. It says it cannot. There's a reference by a foreign key, right? That's what it says here. Department or referenced by the foreign key. So it cannot be. So what about students? Table, table, not table. Or students can be deleted. Probably there is no foreign key. Let's see. Course, if there is no foreign keys, then it will be okay. How can I see that? Describe course. There is no foreign key, only the primary key. So this is also possible. So drop table course and drop. So what? Show me the tables. Only one table. Now I can drop department. Okay, so show table, nothing. So what I'm trying to do, I am going to copy and paste of this. So create, to save time. So create table students, CWID, name, text, and major text. In fact, in this quick demonstration, I didn't intentionally define primary key or foreign key. I want you to focus more on the expression of what we want in SQL statements. The defining primary key, foreign key, that is for database design rather than database usages. Today we will look at how we can use databases. Last week we looked at how we want to define, create database in a DBMS. Okay, so a little bit different focus. So I want to make the database that we are going to work on today a little bit simpler, mainly because to save time. It's not really ideal, but okay. So that is done, and then I want to create another table here. The course, it has a title, CRN number, credit, and instructors. Okay, good. And then another create enrollment. So I want to do here enrollment. So enrollment has a CW ID and a CRN. Here's an integer, CRN integer. They are the same type, right? Although I didn't do any the foreign key in definition, but manually, I still follow that constraints. So enroll is done. So what happens here? We have a department, course, and enroll. 3 tables defined. Okay. Now we want to insert. So first insert here is a cyber. Insert student CWID 123 Adam in cyber major. Done. And then another here. Peter in cyber. And then another students, Chris in CS. As I am doing this, some of you may see, oh, should I do that if I have 10 students? Should I repeat, insert into that statements repeatedly 10 times? Or can I combine them? Yes, you can. Let's see here. I have students, for example, there is the course, coding course 111 by John, and there is another database course by John. So I want to get here. Database by 525, 3, and John. Okay, you can repeat this as many times as you can. Then by having this, insert into course values one time, and then you can have 2 instances together. So hit enter. So here recorded two records are created. And then insert into the enroll values. So I can do here, and then another one here. Okay, so when I do select start from student, 3 students there, select start from enroll to enrollment. Now we are ready to practice. We are ready to practice DML, data manipulation language. So we need to do more like this. Okay, so this students. Oh, we need to have more students. Chris and David. David CS 133. So I'm going to do that. So insert into student values, and then 133 David, CS. So we have select star from students, yeah, 4 students. Enroll 123, 123, 125, 135, 125. So we need to have 3 more. Before doing that, course, select star from course, 2 courses. So insert into course values, defense, and then 550. That is 3 credit hours. Instructor Usman. So we have 3 the courses. Now insert enrollment. Insert into enroll values 125, 525, and then 135. Actually 135 is not there, but 135, CWID. So student 135, that's fine. That person enrolled in 525, that's fine. And then students 125, which is Peter, 125 enrolled in 550, defense, 550. You can keep going like this. Okay, so now we inserted the 3. Okay, so we have this exact same the database, and then let's start from the simple ones first. Let me see. Select from. Okay. So first query is to list the courses taught by John. Simple SQL statements that we looked at here, right? Select star from table. What happens here is the select select an attribute name from relation name, table name, and then condition in where clause. We didn't put any condition here, but in this first simple SQL statement, the query statements has a condition. So taught by John. If you want to see this, then you need to go back to the database schema. And then where is a course? So course here we have a course here, course table. That is a table. So we can select a star from course. Fine. But here, not all of this, but taught by John. If you see this schema, then there is an instructor attribute. That instructor attribute is the attribute that we can filter the records for John. So we need to form the SQL statements in this way. Select from where. Okay, so select. Let's just select this. Star means everything from course. If we simply do this, then everything. But we want to filter that out by describing a condition. Condition is between instructor and the attribute and condition can be formed as a predicate. What the predicate means is the attribute operator and the values. So in this case, we can say instructor is John. Then we may be able to see only 2 records. There is a denial of service using SQL statements, Gianni. What can we do there? Or say 1 equal 1. Then everything. Right? So user can enter only here. Who are you looking for? Then user enter on web, John. Then internally, I can simply add this. Or 1 equal 1. What happens? Or means, although the first condition is not satisfied, if the second condition is satisfied, then it'll be okay. So when I consider first records here, then instructor John, okay, we take it. Second record, instructor is John, okay, we take it. Third record, instructor is John, no, instructor is not John. Then we need to consider next or the condition. It says or equal 1 equal 1. 1 equal 1 is always true, right? So or doesn't matter, it is true. Doesn't matter, whatever that is, it is true. So it will be returned. That's what we have here, right? Although it says, hey, I want to see the course is taught by John, but if somebody came, intervene to add one simple statement, then it can qualify anything, right? That type of things is part of denial of service, and also that is a perfect attack. Why? By having that, I may be able to see who are there. Let's say in the student list we have 10,000 students. The list of 10,000 students, if it is a sensitive data, then therefore we only show. For example, if you want to see the web page to look at your the information, student information from the university, then you enter your CWID, right? Then you can see yours. If you do not enter anything, then it doesn't show to you at all, right? What if internal that the web user interface where there is a text field waiting for you to enter your CWID and hit enter, then it goes into the back-end processor and convert it into a SQL statements and to post on the database. When during that conversion process, if somebody add or 1 equal 1, that simple statement attached to, if it is attached to your SQL statements, then it will return full list of students. That is the first step that your attacker will intrude your database. So if students table is not really sensitive, then you can think of others. What about the payroll table? Then you can see everybody's payroll, right? That is a big problem in the corporates. So it is many times secret. If I know some of my colleagues receives a lot more than I receive, while I am thinking that I am contributing more than that person, but rewarding less than that person, then that is the start points of the conflict. So it is a sensitive data. Usually it is prohibited, but you can see only your data only. But anyway, this is some others. Next one, list students who study cyber major. So we need to have students and cyber major. Let's see which one has that. Here, the student table. Then we have student information and also major there, right? So we can get that quickly by having this. So do not need, well closed, we put that major. So we can do select start from student where major equal cyber and semicolon. Then we can see Adam and Peter. If we go further, let's see. I think list students with the course title that are taken by the students. Student with the course title. So student name and course title. Student name and course title. So student name is here. Course title, course is here, right? So we know, for example, the CWID 123 here. So we know what that person takes, right? So let's do step by step. First step here, let's see CRN number. And then we can extend in the second attempt the title. So CRN first. Then we can do there is a not only students table, but we need one more table, which is enroll. This one table cannot support this query because this table does not have enough record. There is no CRN number. So we need to include this enroll, right? See what happens. If I don't have here anything, then I didn't put any where clause. If I don't put any where clause, what happens? Would it return everything, all possible combinations, or it return nothing? Because I didn't put any anything at all. Then it'll return everything, right? Not just everything, all the combinations. Some of those are not realistic. Okay. What I did here is select from. In this where closure, I put two tables, but there is no where closure. But hit enter, then I have these many outcomes. Many of these outcomes are nonsense because they are not realistic. What happens here is that Adam, who is 123, CWID, when I come here, 123 takes CRN 111 and CRN 525. Only these two, right? But if you see here 123, CRN 123, no, CWID 123. 123, the first one is, this one is also nonsense. First, for this guy, David CS, his CWID is 133, but his CWID is 123. It doesn't make sense. One student has 2 CWID. Doesn't make sense, right? So there are a lot of those nonsenses. But still that is allowed here in SQL statements. The reason for that is they are needed. As you express the SQL statements, your SQL statements, your goal is not just to receive something realistic, but you want to see something not realistic. For example, I want to see who enrolled in my course. Those are things that can be obtained from the current databases, right? There are realistic items. But what if I want to see who does not register my course? Those who do not register my course because not registered, not enrolled in, so that type of items not appeared in my database at all, right? My database represents something that really exists, right, in the real world. If not available in the real world, of course, shouldn't be available in my database. But if I want to see something not available, how should I provide it? Those things can be provided. For example, like that, I want to give you all possible combinations. Okay? Many of them are not realistic because it's not available in the real world, therefore not available in my database. All right. If we do, so what should we do? Therefore, we need to here where clause. As you can see here, they are not realistic because CWID appears twice in this outcome, but their number sometimes not matched. If they are not matched, then they are nonsense. Only if they are matched, then they are sense. For example, here, Adam in cyber security, his CWID is 123. That person is enrolled in the CRN 111. So Adam 123 enrolled in CRN 111. So this type of connection is something really exists. So what should I do? Because of this, then we need to say student.cwid should be the same as enroll.cwid. Not just the CWID equals CWID. So we need to say students enroll. These are from the students. Student enroll, students CWID should be the same as enroll CWID. That is this. If it is the case, then we can see something realistic only. So out of this, we can see only, yes, they are, that makes sense. Adam takes 2 courses, CRN 111 and CRN 525. Peter, CRN is 125. When you come here, 125 takes 2 courses, 525 and 550. So Peter takes 525, and the bottom, there's the Peter takes 550. Okay? What about course title? Course title, that we can find it, not only these two, having this 111, if we come here, if we include one more here, the course, there is a course title, right? This course title can be matched by this CRN. Once you know this is CRN, we know the course title. Oh, by the way, for this, if you want to make it short, should I say enroll dot all the time? Is there anything that I can make some acronym, some short you can do? so that you can do student S, student space S, enroll space E. Therefore, when you come here, you can do s.cwid and e.cwid, so you will get the same result, which is a little bit of the syntactic sugar, right? Okay, so we need to get to this. Then we need to have one more table, which is a course. So that I need to have here course, and then acronym is C, where what should do? As we did above, s.cwid equals e.cwid. Is this all? Let's see what happens if we do this. Still so many, right? Let's see, Adam. Here's it all Adam. Adam takes CWID, fine. But the course, CRN 111, CRN 1115. But this CRN 111, oops. What happens? This is CRN 111 here, the same as CRN 525. That doesn't make sense, right? We checked CWID, so 123, 123, 123, 123, 123, 123, 123, 123. They are good, but CRN we didn't check, like here, for example. Okay, so we have select star from student S, enroll E, course C, where s.cwd equals e.cwid. So CWID, student ID, taken care of, but we didn't yet, because we join student enroll. Therefore, we have a join condition this. Because we have one more class, one more table to join. So we join students and enroll and course. This join, for this join operation, we didn't have here join condition. So we have to say here e dot CRN should be the same as c dot CRN. Okay, if we do that, then probably we'll have the correct ones, right? So CRN here, CWID 123, 123, and then CRN 525 and 525, 111 and 111. So all of this makes sense to us. Now, finally, this guy says a list student and the course title only. Then what should we do? Rather than having here star, we need to put student name. So student name from s.name, comma, and then title. Title comes from the course. So c dot title. But there is no ambiguity, name and the course title along this whole the outcome tables. We may not need that acronym. We could do that. There's no port at all. So if you do this, still okay, name and title. But if you do, although you don't, fine. Because there is no ambiguity. Fine. if we want to change this, title, then it looks like a Adam's title. So you can do this as course title. I think because of that towards. Course title. Then you can see, oh, name, Adam takes, oh, this is course title, database, rather than the title of his position. You can do that. This we practiced already, right? In your first homework assignments. Okay, let's move. So join condition. Join condition, we practiced that, right? Join condition is needed, unless otherwise Cartesian product is returned, which means all possible combinations returns. So if we do join, then we need to have, for example, this join condition needs to be stated. That's what we looked at. List who takes the course. Select that from the students enroll where, yeah, I think we looked at this already. List who teaches which students. Okay, who teaches whom? So to get that, if we do not know, then you need to see describe student, describe enroll, describe. Let's see if it is enough. So who teaches what? Oh, there's no who. So course. Then we have enroll here, right? So we see who teaches. So in this table, who teaches what course, right? When we come here enroll, in what course, who are attending. So we have a CWID. So instructor's name and the student. This, because we know that this CWID, then we need to go back. Then we have a student name, right? So what we need to do is select instructor and the name as a student. And from course. We can list, there's no the order restrictions. We can list anything that we want. But I want to put here in certain order that makes sense of our thinking process. Okay, so we start from the course. So there's a course instructor. That course instructor where we can see the CRN number. Then the CRN number appears in enroll. So we have enroll. So E. And through that enroll table, we can get the student name. So student, NS. And then in the where clause, first we have to do the conditional, the join conditions. So student and the course and enroll, course CRN should be the same as enroll the CRN. Not only that, and that enrolled on CWID should be the same as student.cwid. How about this? If this is not clear to you guys. Anybody has any response? Is it good? Is it enough?
Semicolon.
You said, Billa?
Semicolon to end the query.
Is that all? Yeah, he said in the coding. Yeah, see what happens. Let's say instructor John teaches student Adam. Remember here I put the students because if I say name, then it could be instructor's name. So student. John teaches student Adam. John teaches student Adam. Or 2 times. Probably Adam takes 2 courses from John, right? Who is it? Oh, this is we don't see it real. Then we need to go back to the record itself. This is for the description only. But anyway, we see Adam takes 1 coding and 1 maybe database, and Peter takes the defense from Usman, and Peter takes maybe something else from John, and Chris takes something from John. Right? That's what it is. But if you want to do list of students who are enrolled in the courses, any courses taught by John. Then you need to do here. And then 1 more, right? And instructor should be John. Then among those, the 4 items from John appears here, right? And if you want to, okay. So there is another slide that we can do more. Oh, okay. Here, simply join operation. Then we will see this. There's something left joins. Left join means here, what is a right join? Why a right join or a left join? If you want to right join returns all the rows from the right table and match the rows from the left table, matching rows from the left table. If there is no matches, left side becomes null. That is okay. So here I wanted to see what I want to do from this SQL statements. Select star from student S, left join, enroll E on s.cwid equals e.cwid. So this is something between student table and enroll table, right? Student has here these many students. So Adam, Peter, Chris, David. David's his CWID is 133. But if we see here enroll, he stopped coming into the class. 133 not here. That is possible, right? Some students may skip semesters and come back again. So in a particular situation, David is not enrolled in. Can you see that? Right? Here, we don't, if we join operation, then we don't see it. Is there anything that we can list the students, all the students, and joined it with enroll? But if there is any row not matched, any records in enroll, then I want to still allow in my outcome, but with the null value. That is what this guy can do. Okay, so we need to clean this a little bit. So instructor, let's say student, and so we don't need CWID is needed, but we don't need CRN. We do not need course, student and enroll, okay, but we don't need course. And then we need to students, name students. And then course. Course taken. Then we can see, hey, students, here, Adam, the course taken is 111, 125, 525, 550. But we notice that manually, the David not appearing here. So is there any way that we can include that case in my outcome? We know the motivation, right? Who may need that type of the list? Instructor wants to see that type of list, or the administrator wants to see that type of list? Jen? Huh? Administrator, right? They want to see, oh, who's not in that, didn't come back to this semester. This is money. So let's chase that person. Instructor, we see, we only focus whoever with me teach, right? So that type of, anyway, that is needed, right? In that case, we need to have here, left to join. So, let's see, a little bit of a massage here. So, enroll, and then enroll, no, students needs to appear, right? Rather than enroll. So students first appear here. Because we want to all the students. Me. And then left to join. The language here. Left to join. And then list of that table. So enroll, E. And then rather than where close, we need to, this is only a language issue. We say on. So left to join on here. And condition. Hit enter. Now we need to have a semicolon here, right? So hit enter, then we can see, oh, David is null, right? So clearly, oh, these guys are currently back to school, but David didn't come. That we can see here. No. I was trying to do, I shifted the right student and enroll. What if we have here enroll? Enroll E and then student to S here. What should we do? Is there anything that we need to change it so that we will have similar to this? In that case, this left join wants to keep all the record in the left side table. I swap students and enroll. Therefore, I want to keep all the record in the student table. Therefore, rather than left, we need to put here right join. Then we see the same as that one, right? So left join and right join, that's that indicates which one that we want to list all. Question about this left join, right join? From Gianni first?
No.
And from everyone on Zoom? Okay, move. Aggregations. Gianni, what is the aggregation function? What is the aggregation? I taught you in the previous class, taught you. Aggregation is a function that takes multiple values but returns only one value. That is aggregation. What is any example hits upon you?
Integers? Maybe?
Huh?
Integers? What are strings?
Let's say average.
Yeah.
I give 100 students the points, and they give me an average. How many values? One average. Any other similar?
Module?
I have a students list. If I say count, will there be more than one? Only one number, right? When I say count, minimum, one value. Maximum, one value. Median, mode, those are all one value, right? Sum, so what is the sum? What is, all, those are all aggregations. And so, for example, list the course credits for each student. Okay? That type of things is especially once wanted by the administrator. Administrator does not really want to focus on who takes what course, but the administrator wants to see who takes how many courses. Right? So that is what we want. How can we describe that? So we see here the course has credit numbers. Course has credit numbers. So we have a student and student name. From here to course credit, then we need to, there is a intermediate table that we need to include, enroll. Right? So we looked at this many times. So see what we have. Okay, here, course, enroll, and students. And then we have two join conditions. And then what we have? We have a student's name, right? So name as students, And then we need to have a credit, right? Credit. When we do credit, are we going to do, okay, let's do credits only. Yeah, first of all, let's do it. See what happens. Then we see student Adam takes a three credit. Student Adam takes 3 credit. Oh, I do not want to having 2 records for the same person, Adam. Is there any way that I can group by students? So if they are the same name, students, I can group it. For Adam, it appears twice, group. Peter appears twice, I want to group it. That's what we want to do. So to aggregate the function, aggregation is that I want to sum not only the list of the credits, but I want to do sum. This kind of function is needed. But if I do sum only, then it doesn't make sense. How can I sum them? I can sum only if I group by student name, right? According to student name, I can group. As I group based on student name, I can sum, or I can count. I can do something, right? That's what we do here. So I want to make it sum here, and then group by as name. So that's what it is. So if I do hit enter, then nicely Adam and Peter are grouped. If they are the same name multiple times, I can group them all, right? Or somebody says, I want to see rather than the credit number, but how many courses that person registers. Then we need to put here count, right? So we want to count. Then I can see 2 courses and 1 course. When you do count, it's not necessarily a credit, count credit. You can count title, CRN. Still, CRN. What happens? CRN is a field of ambiguous because CRN appears many times. So I can do here CRN, CRN or CRN. Okay. Again, go back. And I want to see the credits, but group by. The left join and group by. So go back to the left join. Where is the left join? Okay, here right join, in this case, right to join, but I want to make here group by student name, students taken, and then I want to put here, rather than CRN, credit, sum as there's no credit. enroll and there's no credit here. So we need to change this to enroll. Oh, we need to have all. This needs to be and then we can do left to join, enroll and course. On enroll dot crn equals c dot crn and group by that, and then I think credit that is looks okay. Let's see. This is a little bit complicated. Let's see what happens. If there is a wrong, then we will fix it. Oh, good. See this? What happens? I put here tuition. You see here, this guy says Adam takes 6 credits, Peter takes 6 credits, Chris takes 3 credits, David takes 0. But I put here not only this credit, but I here multiplied by 5,000 as tuition. Let's say 1 credit is 5,000, then 6 credit, 30,000. So tuition is 30,000. Adam needs to pay 30,000. Peter needs to pay 30,000. Chris 15,000. David no nothing. So a little bit of an extension from your the lecture notes, right? This is a little bit of the extension. I want to see that. I'll give you 1 minute to take a look. Question, Gianni? Any question from online? No. No response
All good,
means
Professor.
no. Oh. Say that again?
Oh, sorry. I mean, all good.
Okay.
No questions.
Thank you. Thank you for response. Okay. I think this is for from the database portion, and we will move to. I want to close this by quit, and then I will go for the operating systems. To slideshow setup. Okay, operating systems. So what is an operating system? There's a program set. So you can make operating systems. Operating system goals is to execute user programs and make solving users' problems easier. Make some computer systems convenient to use computer hardware in an efficient manner. Gianni, how many operating systems do you know? Hmm? Did you take a Linux class?
Yeah.
Isn't it an operating system? You are working on MacBook, so iOS isn't it an operating system? When you were young, you used the Windows in high school. Isn't it an operating system? So you know all of those. So those are the operating systems. Does it help you to run any programs? Yeah. PowerPoint, that's a program. Program as a, there's application programs, right? Okay. So operating systems definitions. Operating system is a resource allocator. Operating system is a program controller. Operating system is so many things. Security controller, access controller, a lot more than what it was before. So this is one small slide, tells you how a computer system can start up. So basic idea here, the computer systems and operating systems. Without operating systems, your computer does not do anything, right? So you need to run the operating systems. Where that operating system located, when you turn off your laptop, where is an operating system located? It is located in your storage, right? Your storage. Maybe SSD storage or hard drive. So it is stayed there. So when you turn on your computer, then operating system should be where? If your computer is alive, your operating systems still in the storage or there's on the memory, right? So it should be on the memory. Therefore, once your operating system is on the memory, then after that, everything that you want to do can be taken care of by operating systems, right? So operating system handles whatever that you want to on your laptop. How come it is possible? Because operating systems is now on the memory. It should be loaded on the memory. If it is on the hard drive, then nothing, doesn't do anything. It is simply plastic, right? Even that operating systems enable some of the file that you saved on your storage. Last night you have your homework assignments using Word program and saved it, so it is in your laptop storage. So you turn on your laptop, therefore operating systems is loaded. From there, your operating systems bring that your file from your storage on the memory again. Therefore, you can see your file on your terminal. Makes sense? Okay. My question. At the very first time. So once the operating system is on the memory, then everything can be taken care of with the operating systems. So who bring that operating systems on the memory? first, at the very first time. Bring something from storage to memory can be done by operating systems. So once operating systems, then you can save it, you can bring it back, save it, bring it back, and edit more and save it. Then it can be storage, and you can double click it and bring it back on your memory, and then you can see them on your terminal. Fine. As far as you have your operating system on the memory, you are fine, right? So who first brings the operating systems on the memory? That is a startup program. That is called the bootstrap program. Bootstrap. Small program. Your operating systems are on your RAM, right? Random access memory. This is a memory. But this bootstrap program is on ROM. But we say many different versions of ROM. So EPROM and some other ROMs. Small program. That small program runs on ROM. It doesn't need to be on RAM. ROM, read-only memory. This itself is a memory, like here RAM memory. So ROM memory and RAM memory. In the ROM memory, ROM is very expensive, and it can be extended, bigger and bigger. It's small. It cannot be. It is also volatile. So your laptop should have a small battery running inside all the time. If that battery dies, then bootstrap cannot do work. You cannot run your operating system even if you turn on, even if you have power supplies from the wall, power fine. But if there is a small battery always on your laptop, if it is died, then ROM is died, bootstrap is not available. So there is nothing. There's nothing who can bring entire operating systems into RAM. There's no start up stakeholders. Bootstrap. So bootstrap is something like this. Bootstrap from cowboy boots. Gianni, do you have? I think you have cowboy boots at home, right? Cowboy hat? No, we are talking about the boot. We'll find out if there is a hat strap, but bootstrap. So bootstrap is a long leg here, right? So you can not wear it very easily, right? So always there is something in the back, some of the straps, to pull that up, right? That's a bootstrap. So cowboy boot itself is operating systems. Operating system is available and volatile, viable only if you pull that bootstrap on. So it can be on your foot. That's a bootstrap. There's another important concept called the interrupt. Interrupt is a signal. See, when you run on your the applications, sometimes you interrupt it. Is there anything that you interrupted while your application program runs? For example, you're working on your Microsoft Word. Don't you do sometimes interrupt your Microsoft Word? Yeah, sometimes you can do Control S to save, right, periodically. Although it may save automatically, but you may want to do manually, periodically. That kind of things is an interrupt. Or sometimes your operating system is up on your memory, and therefore you can see on your terminal while it is running. Sometimes I want to print it, so do Control P for print. That type of things is an interrupt. Lots of interrupt possible in the operating systems. Lots of interrupt. So there's a software interrupt and hardware interrupt. Software interrupt, there's so many things that you can, some menus, you choose some menu and click it, then that it interrupts your main procedures. Hard interrupt from your keyboard, mouse. Therefore, for example, Control C in your Linux operating systems, then something can be stopped, right? Some process can be stopped by an interrupt. There are so many different kinds of interruptions possible. And then there is architecture issues. Modern computer has this is a typical the computer architecture. We have here storage and the memory. This is RAM and CPU. And also some of the devices, maybe your USB device, maybe some of the internet interfaces. Anything that you want to run on CPU, then that program should be first loaded on this memory. Therefore, this CPU can be able to run your program. As that is running, if it needs to wait for internet data, then it maybe somehow there's interrupted, somehow idlings, right? Or some data comes in, I/O. That type of things can be done. If you see the memory itself, this is a memory, right? See the memory itself, then there's some portion operating system resides. When you turn on your laptop, nothing here. The first thing that Bootstrap needs to do is to bring that operating system from the storage that is loaded by Bootstrap. Once the operating system is loaded, then you can see, now you can click something. So some job can be loaded, more than one. There is a multiprocessing also possible. So your CPU is not only one, but more than one. So you have separate register sets and caches. They are all working at the memory, same memory. So you have here storage. So some program loaded. This can be handled by this CPU. Some other things handled by some other CPU. So multi-processing possible. Multi-threading. One CPU, one code runs only. So one register and one But if we see multi-threading and multi-process, then let's say this is two CPUs. This is one CPU, so another CPU. In this case, one CPU only, but it runs different sets of registers. So multiple programs may be able to run on the same CPU. That is multi-threading. Virtualizations from the one hardware, one CPU runs, that's fine. One operating system runs. Kernel means kernel over one OS. If you do virtualize, then you may be able to have multiple virtual machines. So here, kernel of operating systems one, which is Linux, another kernel which is Windows, another kernel which is iOS, another kernel something else. It is possible. With that, so now we are talking about operating. The Python. How can Python run something like this? I think you already registered the operating systems, right? So, for example, Python. My case, it is not run. So if I do Python 3, then it runs here, right? So Python runs. So version of Python that I have is 3.14. This slide says 3.13. Doesn't really matter, right? So there, in your Python, this is Python. User interactive Python. Okay. User interactive Python. Python, when you first run, that application program, Python 3, Python brings something, the fundamentals. It doesn't bring something extra. One of the extra that module that is available in Python on Python is OS, operating systems. So if you want to run something about the operating systems, then you need to import OS. Here, triple greater than sign, that is the prompt statement. Okay, when there is a triple greater than sign, then you can issue Python statements. So first Python statement that I issued was import OS. Why I import OS? It's because OS is not coming up to the memory by default, because all other fundamental modules appears. So we have to bring it up extra in order to use something available on the OS, right? If you want to see manual, then you can see help. Then you will have help here, then OS, type OS, then you can see something about OS. This is a manual, right? It says OS routine for NT. The NT is the next technologies. This is a long term. It's 20 or 30 years ago terminologies. And the POSIX, depending on what systems you are on. So this is usually for the Windows. This is for the Linux, Mac OS, and things like that. some modules. Following documents is automatically operated from the Python source files if you import to OS. Let's see. This guy says automatically, so the new versions automatically up. We'll try that. Anyway, this exports all the functions from POSIX or NT. So we have OS path, os.name, os.curdir, current dir, par dir. This is a parent directory. os.sep, path separations, delimiter. So greater than sign, or for Linux and Mac OS, path name separator is /. For Windows, double backward slash. There's difference between Windows and the others. os.extsep, there is extension separations, alt separation, path separation, line separation, and those. And then there's a class. The features available on the class is dir, is file. These are the method. These are the, you guys do not know the method yet, but something that we can use. Okay, so if I go this further, then you may be confused. So I will. So if you want to quit, then you need to press Q to quit, and this is help. We're still in help prompt, right? If you want to quit it, then you need to quit. Then you have here greater than sign. This is a Python prompt, because we already. Let's quit. The Python can be quit here, because Python is functional programming. If you do quit, then it doesn't quit. Here help, you can quit by simply quit, because this is not Python. This is Python prompt. If you quit, then it complains, because it is not function formats. It complains. Oops, it does. It didn't complain. I think this is a little bit upgraded. So usually we need to quit, open and close parentheses. But anyway, Python 3, you may be confused. Let's see if we have OS. OS is not defined for its OS name. OS is not defined. So we need to do import OS and OS.name. Then I can see, there is a POSIX, because my OS is like Linux, right? OS child dir, os.chdir. And then if it is a function, then you need to have, this is simply a name, like a field name. These are the functions, open and close parentheses, right? So you need to have that. If I do chdr, this is a change directory. If I want to see getwd, get, I want to see. cwd means current working directory. If I do cwd only, then see what happens. It says it's not. It says it is a function. It is a built-in function. If it is a function, then you need to have open and close parentheses, so that where am I right now? Current working directory. I am now /users/jun. So if we do quit, then pwd, then you clearly see I am in users/users/jun. That is exactly. So this is, when I do here, this is pwd means this is a print working directory. CWD means it's a current working directory. PWD, this is a command running on this operating system. So operating system. This is operating system's prompt, right? CWD is operating systems, a command. This is a program coming from Python. This is a Python program. So go back to Python 3, and then import OS. So by having OS, I can make some of this. For example, list dir. So OS dot. By the way, this is a module, OS module. So I need to say that module name. That module has list dir method, list dir function, list dir some capabilities available. So when I specify to run that function, then I need to link this module. This is a container, and something contained in that container by having dot notation, so that I have os dot list dir, then it can show to me all the list that's available. For example, quit. When I do ls, that is ls is a list command in operating system itself. This is the statement in Python when we import OS modules. So this program somehow controls my operating systems. That things can be seen here when I do ls. Then, for example, desktop, that can be seen somewhere here, desktop, right? Yeah, desktop. Library, I think somewhere there. Let me find out from here. Let's say this shows more than. If I show everything about that, then I need to do ls -a, so that I can see everything. So example .pnc, then I have here .pnc. Mercy, I have here Mercy. Movies, dot idle erc, then I would have dot, yeah, idle erc. So this is something that this is an operating system command. Similar things can be done by your program, Python program. So you can do more. For example, CPU count, how many CPUs? Python 3, import to OS. I do not know how many CPUs, but if I run CPU modules on the Python, then I can see that. What? 14 CPUs? Amazing. Is that right? So OS dot get login. Who logs in? So tight. Okay. We have some accident here in classrooms, so don't worry. Online students. So give us a few seconds to restore. Okay, so we have a projection on. Okay, I think this is the previous scene, right? Anyone online students responded if you are okay? I mean, if we are okay on this screen, we are on the same screen as before something happens to us. Anyone replies?
Professor, we only see you. We don't see the screen sharing.
Oh, okay. So what you can see right now?
You, Professor.
Oh, me?
Only, yeah.
Let's see. Oh, this is not that one. So where is Zoom? Should I? Where's the Zoom? Oh, yeah, Zoom. But you can see me, right?
Yes.
Zoom. If I start to zoom again, let's try to see. Let's try to see again. Oh, we have only one student? All gone? You are Mohammed, right?
Yes, but all of us are in the...
Oh, can you see other students there?
Yeah, I can see them, yeah.
Oh, yeah? Can I do join or start? Let's see if I do. How can I go back? If I do this, do you allow this website to open? I think we are on, right? And, oh, there's no share. I'm host. Then I think I should be able to show the screen. Okay, here, share. Okay. How about now?
Yeah, it's working, Professor.
Okay, good. Okay, is this the same screen to your best as before?
Yes.
Okay. So this is a get login. So from even in your Python execution, you can see who is in right now. So the key thing here is your Python program can access somewhat available on your the operating systems. That's what I can say. Okay. So you can practice some others if you want. Similar to OS, we have a system. Difference between system and OS. OS is generally the operating system itself. System is where the Python program runs. So a Python specific system, that is sys. So import sys. And then if I do sys os get environment, get environment and path, then I can get the path expression. That path expression also can see in another module, the sys module. Sys module has path expressions. So there is a little difference, but in path expression, everything can be in the list format. See here, open square bracket and close the square bracket. Here, in one list, everything in one quote, open quote and close quote. Here, multiple different things in the comma. Okay, this is one element, and the second element is this. So we can see library, frameworks, Python dot framework, version 3.14, library, Python 3.14.zip. See if that is available in another, maybe here. That's similar to this, right? It is a library, Python the frame, version 3.14, bin. This is a zip file, maybe something here. That is, instead of bin, this guy said Python 3.14. This is a specific binary file, which is a command. So come here, then you can do Python 3.14, which is Python 3. Similarly, sys.arg, then you can see, oh, this is current. And then sys hash info. Using your Python program, you can do some of the encryptions. Then hash function is needed. Then what is the size of a hash? Remember that when you do sys, then this is a current system where this prompt is located, which is Python 3, right? Python 3 itself is something that this sys can point to. So something about your Python 3 now can be handled by sys. So when you do sys.hashinfo, then this guy tells us how your current Python can do for your hash functions. So when I hit enter, then the size of a hash is 64 bits. So modulus that you use hash is this, very big number. Gianni, can you read this number? It's too big, right? I can read, for example, from here, there, and there. Then this is 9,2013,006,093 Oh, this is a million. Oh, this is billion. Something zillion, maybe a lot more than that. Algorithm is a SIP hash, SIP hash 13. Hash bits 64, seed bits 128, cutoff equals 0. This is something about your cryptography. The functionalities, if it runs on this particular Python programs. Comparison between sys and OS. Purpose, if you do sys, then provides access to system-specific applications, functions, Python, runtime, and environment. So about system-specific means, in this case, Python. OS modules provides an interface to interact with the operating systems. In this case, Mac OS, because I'm running on Mac OS. Sys modules handling command line arguments, controlling Python interpreter behavior, dynamically modifying module search paths. On the other, this is because this is a Python specific. This is OS specific. So interacting with the files and directories, this OS can read and setting environment variables. OS can manage processes and system calls. So each module that you can import on your Python may behave something specific, something different. Okay. This is the end of the operating systems. Any question about operating systems? Okay, then close its operating systems. And third modules. What is it?
Can you please elaborate on what's the difference between sys and OS?
I didn't hear your first part of your question.
I said, can you please elaborate on what's the difference between the sys and the OS?
As I said, this is something about your current this environment, this virtual environment where there is Python is running. After this Python runs, after this, everything about your when Python comes on your computer, then there is some virtual space where their Python 3 is running. So everything inside can be controlled by sys. If you do OS, then even bigger than that, entire operating systems. Commands, there are so many different commands available. So you can do, for example, help. Then if you do OS, those are all the commands that you can see. So many different things, right? This is for the OS. But if you do sys, different sets of functions. The elaborations is much more, but we're not doing for the Python today. This is something about operating systems. If you want to, I think, whose question is this?
This is me, Bilal.
Bilal. Yeah, I think you can find it on your own. If you are interested in, then as I shown here, help, lots of those. So you can, as I shown here, some functions available that's associated with the OS, that's fine. If you do sys, same thing. But yeah, we do not have time. So I want you to elaborate on your own, okay? Now, Python. Reason I am hurrying up today, if we do not start Python, then next week I'm not going to be with you in person, not in Zoom. You need to follow my recording only. So somehow there is the technical issues, so I'm going to avoid that. So do this. Okay. Well, the basic idea here is our Python. So what we did so far, we've done databases, right? We've done operating systems. This class will cover 4 subjects: database, operating systems, and coding, finally networking. So coding, I think it takes at least 6 weeks, sometimes 8 weeks. And network, I think about 3 weeks. So we already had, I think, this is the 4th week, 5th week. So we need to hurry. Okay. So our Python code runs on our lab on Google Colab. Okay. That's it. There are many computer languages available. Host languages, starting from Fortran and COBOL. Currently Python, C++, Java, Swift, and a little bit of advanced high-level codings, maybe some other sorts of possible, right? And application languages, SQL, all. Features of Python, easy to learn and easy to use. There's a little bit of expressive power. Not really powerful, but okay. It is interpretable, which is not really executable. What that means is that the Python code should run on Python environment. You can make it Python independently. Everything should be compiled and make it executable. But Python, pure Python language itself, there is an interpreter, not the executor. It doesn't do compile, not like C, but like Java. Java runs on Java, a virtual machine. Similarly, Python runs on Python virtual machines, virtual environment. Okay. To evaluate someone's Python files on your system, then you need to run Python first. You cannot simply run it with the no Python environment. That is what it says here. That relates with, for example, the modules, sys module and OS modules. Sys modules, that is Python related modules. Not only Python, but because you see the Python modules by importing Python within Python. I mean, importing sys within Python. So that system is Python systems. Okay. Cross platforms. Python code can run on. You can develop it on your Windows, but can run on run on your Mac OS, vice versa. Why? How? When you run it, you simply run it on your Python environment already set up, whatever platform that you have, right? Python file, that's a plain text file. Plain text files. It's not like a Word file. Word file is not plain text files. Microsoft, but Python file is plain text files. Remember that when you submit your Python homework assignments, it should be plain text files. So that when I run your submission, I run your text file, which is a Python file, using the Python that I installed on my laptop, not the way that you created it at your side. Free and open source. You can download it free. It is also object-oriented, dynamically typed. You don't need to stick to, hey, this is a type ABC. This is a type string. This is type integer. This is a type double-sized integer. We don't do that. We simply use it. That is That is, we say, easy to use. Extensible. Python can be extended further because there are lots of big communities of Python, which means more and more modules created. Okay, believe it or not, using Python, you can do whatever that you want to do. You can run on your, for example, your a musical instrument. You can draw something, and you can, you can communicate with some of the external host. Extensible. Extensibility of Python is a lot more and wider than other languages like C or Java. That is the strength of Python. Large standard libraries, large, really large. Why? Because so many users creates more modules. Therefore, as far as we import it, we can run it. Graphical user interface, powerful. It can be integrated with others. Unlike other languages, this is very, very important. Python is indentation sensitive. It is a must. Indentation. Instead of code blocks and indentation, instead of code blocks, we use indentation. Proper indentation is needed. So we'll see that. And the deeper features possible. And this is something that we want to learn. Okay. And then we want to do Google Colab. Okay. So I want to bring up Google Colab. Oops, this is not. Okay. So what you need to do, open up and Colab and upload. Before you do this, on your Blackboard, when you scroll down, then there is a here. This is a lecture notes for operating systems. Lecture notes for SQL, and then this is a lecture notes for the Python. 3 modules together today. And then the last one is IPYNB files. You download this, click that, and it can be downloaded on your, I think, download here. This, right? So what you need to do, upload and browse and go to that download. Pick that up, open. Okay. So this is what you have. Can you bring that? Gianni, you know this one. So I created here 505, getting ready, homework 5 from here. Homework 4 about SQL, so reserve that. So today you will have 2 homeworks. Homework 4, that is about SQL. Homework 5, that's for this. So I put here to-do list. So you need to submission. You cannot submit here directly because this. Your Blackboard, you downloaded already, IPYNB laptop. That's what I did, right? And I open up also Google Colab, putting that up. That is this. and I am working on here, the way that I can work, a little bit of a practice. You don't need to do any further. Here, print statements. Statement to display your name. If you want to see that, then at the bottom, I said here, cheat sheets. So if you click this print, then you may be able to see what does that means. This is a print statement. Print function prints specified message to the screen. This is standard I/O, standard output, or the other outputs, but in this case, we standard outputs. So this is a syntax. This print statement takes parameter, multiple parameters, 1 or 0 or more parameters. If you want to put their separator, fine. And we will use this file flush. So you can read this and then come back here and practice that print. For example, in this case, I said print, my name is John Yoon. This is one print statement, right? I want to run this. If we want to run this, I want to clear this. So this is a code. If I click this, it runs. This is the output. My name is John Yoon. Okay. A little more. I declare the variables. Right now, you see simply, we don't really look at the Python yet. So next week, we'll start with the variables and everything there. So right now, I wanted to see, this is a placeholder, first name, like a container. That container, I want to contain some of the string, some of the values, John. Another container, I hold Yoon. This is a variable or placeholder or container so that I can use this. Or you can say this is a label. You simply label it. So I want to print my name. Remember that print can do multiple parameter. So this is the first parameter, second parameter, in between comma, and then third parameter, and then finally dot. So if I want to clear this, if I run this, then my name is John Yoon, right? Similarly, I can do print my name is, and then first name, comma, first name and last name, comma. If I do this, then I want to see this first name is not the same as this first name, right? The second, here first name, everything within this quote. And also color coded. Color coded is simply service to you. First name and last name. This first name is evaluated. Therefore, instead of this, because this is simply a label, this is simply variable. When this variable is evaluated, it brings up what it contains. So John, instead of a first name, we'll see John. Instead of a last name, we see Yoon. But if you have everything in this string, quote and unquote, then this is simply copy it. Everything in this quote and unquote, this guy would not evaluate. Although they are similar name, exact same name, doesn't care. Everything is ignore, not evaluate. However, if you want him to evaluate it, hey, wait a minute, I want to evaluate this. Can you evaluate it? Then you can do here backslash. And then I do not want it to evaluate. I do not, anything in backslash, then this guy needs to be evaluated. So see here, it says John, right? Previously, when I don't have this, when I bring my mouse on this first name, no. This guy is John, but this guy shouldn't be. Okay, when I run this, okay. Okay. I'll explain this later. This is too much. Okay. So run this. Move further. This is a function input. Input function. If you want to see, this is too much today for today. We do not have enough time. So, so what is homework assignments? Do I do here homework assignments? Open, save. Yeah. You don't need to worry about all these statements. Okay. Simply, what you need to do is save all in .py file. Open .py file. Remove all unnecessary statements or resave Python code, including proper Python commands only. Make sure that your file can run in Python interpreter. So what I want you to do is I want you to bring only the code only. This colab notebook, this is a notebook, has lots of text. It is a combination between code and text. This is a code, this is a text, this is a code, text and code and text and code, right? So what I want you to do, some of you do not know, do not have IDE, integrated development environment, like Python or Visual Studio Code. But if you want to make something here, then you can simply do, I open up colab, new colab, so new notebook. Right now only the code. So going back to the previous tab, what I want to do here, this code can be here, make cell, and then copy cell, and come back here. I want to paste it. Then there is a pasted. The previous ones I want to remove it. And then I can bring more. I do not want you to bring everything. Simply a few of those. So you can do not only having this extra, but you can do simply highlight and copy and paste by your shortcut key, and then you can paste it. Okay, only that much. You don't need to do all. This much. Okay, and then you can save it. You can say this is homework 5. Hit enter. This is homework 5.ipy nb files. So you can download this by clicking file, and there's a download. Here, I want you to download it, not IPY NB file, but .py files. download the .py files. I downloaded it. Come back here. Then I have here .py files, right? Do I have another homework 5? Somewhere I probably has homework 5. Because of this. I want to remove this. Okay, this is a homework 5. This is what I want you to submit on your Blackboard. If we want to test this to see if that is pure text files, plain text files, then you can open up any of the editor available on your platform. Let's say text editor, open up. Then I can see here. This is a comment, triple quote and the triple quote. There's a comment. And first one here, if you do not want to, you can remove this. And this is a code that I had here, right? There is a code. Code is on my files. So you can submit this. If you want to make sure that if that works or not, then you can do cd downloads and then ls homework 5.py. So it allows. So I have a homework that once. So you can do Python 3 and hw5.py. Then you can see here, my name is John Yoon. My name is John Yoon. Two things can come up. Same thing here. When you run this, my name is John Yoon. My name is John Yoon. Exact same ones that I have here. Then this is your homework assignments. Okay, so you can submit that. But by the way, here I do not want you to do John Yoon, but your name here. Okay. Some of Gianni. I don't know your. What was your last name? Power. Something like that. And then you can run this. Then my name is Gianni Power. Put all of your names here. That is homework number 5. So homework number 5 is very, very simple in codings. You don't need to know anything. Simply this kind of small Python statements copied and save it purely .py files like this and submit these files. Okay, that is the homework number 5. Homework number 4 will be about Python, the SQL. Any questions?
Can you do the homework you checked it?
Check your Pythons here. This is a command. Remember that Python is an interpreter. This is a file name, py.py, right? Before I do, I need to do if there is any .py files. So I have some other files from other course here. ls-l.py files. Then this .py files just downloaded 275 February 17, 12:56. So this is today, right? So make sure that I have here. Then I can do Python 3 and then homework 5.py. And if it runs the same as that I run here, then this file is the same as the file that you downloaded. This is a perfect file that I can grade. Any question from online? Let me see if we have online students.
No, Professor.
Okay, we have Bilal, Kunji, Mohammed. Okay, If there's no additional question, then we'll stop here. Next week, all the course materials will be posted on your Blackboard with a simple homework assignments. This homework assignment, the HW5 homework assignments is simple exercise. So we need to practice some of the protocols, the way that you work, and the way that I need to receive from you. Okay, it's not coding itself. It is some of the logistics from your Google Colab all the way to the Blackboard where I can grade yours. All right. Other than that, I'll see you in person 2 weeks and virtually next week. Have a good rest of the day.
Okay. Well.